In this lesson, we're going to talk about a technique called factoring a difference of squares. Example 1, expand the following binomials. So these are binomials. We've already talked about these before. So this is kind of a recap for you, but it leads into what we're going to talk about. So FOIL is an acronym, first, outside, inside, last, which you don't need to know. It just helps you remember getting all the combinations right. So I'm going to multiply the x times the x together. So those first two, I multiply them together, I get x squared. Now the x and the -3 are on the outside of these brackets, so I multiply those together, I get minus 3x. Don't forget the sign goes with the number that follows it. Then I move on to what we call the inside, or the 3x combination here. 3 times x is 3x. And then I multiply the very last terms in each bracket, I get minus 9. This gives us, we have some like terms here, this gives us x squared minus 9. Okay, let's try another one. So without going over FOIL, without kind of focusing on first, outside, inside, last, we're just going to make sure we get every combination. So this 7 in the front needs to get multiplied into both terms of the second bracket. So 7 times 7 first is 49, and then 7 times x is 7x. Now I need to multiply the second term in this bracket by both terms in the other bracket. So this way I get every combination multiplied out, and that's a negative x. So negative x times 7 is negative, or subtract, or minus 7x. And then negative x times positive x is negative x squared. And I have some like terms here too. I have a positive 7x and a negative 7x, and they cancel each other out and make 0, so I'm left with 49 minus x squared. One more. We're going to expand by first multiplying x into the first term. X times x is x squared. X times 2 is 2x. Now the next term, negative 2 times x is negative 2x, and negative 2 times positive 2 is minus 4. Again, our like terms in the middle cancel out. You're seeing a pattern here for what we're working on today. This gives us x squared minus 4. What do you notice about your final answers? So what we noticed here was that in each case, the two middle terms canceled out because we had one plus and one minus, because there was a minus and a plus here. So our answers, our final answers, just have two terms left in them. And both of the two terms that are left, each of them have an x squared in them, which is a perfect square, x squared. But the other number that we were left with is also a perfect square. 4, 49, 9, those are all perfect square numbers. So our answers are all perfect squares. Let's talk about perfect squares. State the positive square root for each of the following perfect square monomial. Remember what a monomial is? It means one term. So these are all one terms here. This up here, that's a binomial because it has two terms. It has an x and then a plus sign and a 3, two terms. So I want to take the positive square root of 25. The positive root of 25 is just 5. So the positive square root of 25 is 5. What's the square root of m squared? Well, the power of 2 and the radical actually cancel each other out, and we just get an m. And that's because, let me just put this below here, m times m is equal to m squared. So when we take the square root, so it's similar to saying 3 times 3 is 9. So the square root of 9 is one of these. The square root of m squared is one of these here. So putting these two together that we just did, a and b, 25m squared, putting it together as one larger monomial, the square root of it, the square root of 25, we already know is 5. The square root of m squared, we already know is m. So the square root of 25m squared, the square root of 25m squared is 5m. So what's the square root of a squared going to be? And look at what we talked about here. What's the square root of a squared going to be? It's going to be just an a. And the square root of 1 is 1. What's the square root of 16x squared? So first I'm going to take the square root of 16. The square root of 16 is 4. The square root of x squared is x. So that is just practice with how to take the square root of a perfect square. So all of these terms here were perfect square monomials. They were one term, and each term was a perfect square. And that's leading us to this factoring method called the difference of squares. So the difference of squares is used when you have a binomial, that's two terms, and the binomial has a negative sign in the middle. So that's important. That was, if you look back to the answers we got for example 1, they were all like that. And each of the terms of the binomial is a perfect square, and that's what happened with example 1, with the answer for example 1. So these questions here all look like the answers that we got in example 1. There's no term with just an x in it here. They canceled out. They would just have the x squared minus 25. So these all are going to maybe fall into this pattern here. So factor if possible. First thing we always look for is a greatest common factor. Do any of these have a greatest common factor? Look at them all. Do any of them have a greatest common factor that I could factor first? I could factor a 2 out or something like that. Could I factor a 5 out here? Is that a greatest common factor? No. So there's no greatest common factor. So now what we do is that's the only factoring method we have so far. So what else can I do? I can't take out a greatest common factor. Well, I've got some steps here. My first step, if it's a difference of squares, it must be in this form, a squared minus b squared. So it's got to be a binomial. It's got to have two terms. These all have two terms, all of them. And does it have a negative sign in the middle? Well, let's look at this one here. Yes, it does. It has two terms and there's a minus sign in the middle. And each of the terms of the binomial is a perfect square. X squared is a perfect square. Its square root is x. 25 is a perfect square. Its square root is 5. So it's in the right form. It's a perfect square subtract perfect square. We have that here. So step 1 tells us this is a difference of squares. So since it is a difference of squares, how do we factor it? Well, here's the first step. We're going to set up two brackets like this, one with a plus sign, one with a minus sign. And it doesn't matter if you put the plus sign or the minus sign first. So just to show you, I will put the plus sign first. So leave spaces because we're going to put some terms in there. Okay. That's our next step there. So first step is to identify that it is a difference of squares. The second step is to get our brackets up. Third step, we're going to fill in the empty spots of the brackets with square root terms. So let me switch colors for this. So the square root of x squared, that is x. That goes, since that was at the front, it's going to go at the front. The square root of 25, forget about the negative, the square root of 25 is 5. Since that was at the back of this binomial, it's going to go at the back here. That is factored now. X plus 5, x minus 5. I know it's factored because there's no plus or minus sign sitting out in the open. They're all enclosed in brackets. So that's totally factored. X plus 5, x minus 5. And our fourth step is to check by expanding. So I'm going to check and I'll put it in red so that you can identify it as a check. So this is my check. I've already factored. I want to check my factoring. I'm going to check with binomial expansion like we did at the very first thing we did today. So first I'm going to do x times x, that's x squared. And then x times negative 5 is negative 5x. Now over to the positive 5 times x is plus 5x. And positive 5 times negative 5 is negative 25. These two cancel out just like they did the first thing we did today. These two cancel out, so we're left with x squared minus 25. Is that the original question? Let me erase all the markings I put here. Is that the original question? It is. So that means my factoring is right. So let's try that again. B. First of all, we have to look at our criteria here. Is it a difference of squares? Is it a binomial? That's two terms, yes. 1, 2 terms. Is there a negative sign in the middle? Yes, perfect. And each of the terms is a perfect square. Yes, 100 is a perfect square and a squared is a perfect square. So now that we know it's in this form, we can set up two brackets. Oops, let's go with purple. Set up two brackets here, one with a plus sign, one with a minus sign. It does not matter which one you put first. That's step 2. Step 3, fill in the empty spots with the square root. So the square root of 100 is going to go at the front. That's a 10 of both brackets. The square root of a squared is going to go at the back. That's a. That's it. That's factored. That's the end of a difference of squares. And we would check with expanding, but we'll skip that. Let's just keep moving on now that we're on a roll here. C, x squared plus 28. Here we go. Do we have a binomial? Yes, we do. One term, two terms. Is there a negative sign in the middle? No, there's not. What about the rest of it? Each of the terms is a perfect square. Yes, this is a perfect square, x squared and 81, the square root of that is 9. But I don't have a minus sign in the middle. So this is not a difference of squares, so I can't do any of my steps here. The only thing I can put here is cannot be factored, or I could write not a difference of squares. Cannot be factored. We already checked for greatest common factor. Remember, we did that at the beginning. There was no greatest common factor, and I can't use difference of squares. So I can't factor this example here. And that's why the question said factor if possible. There's always some thrown in there for you in your homework that are not possible, just to make sure you're paying attention to the criteria. So down we go to D, x squared minus 1. Let's try again. It's a binomial, 1, 2 terms. Have a negative sign in the middle? Yes, it does. Are each of the terms perfect squares? Yes, this one is, and 1 is. Remember, we did that in example 2, the letter E. We did the square root of 1. So we know that 1 is a perfect square. So we can go over to our steps. We now know it's a difference of squares. We know it's in the right form, so we're going to set up 2 brackets. Let's move it over a bit here so I don't crowd my other ones out. So I'm going to have a bracket with a plus sign and a bracket with a subtraction sign. Fill the empty spots with the square root terms. Square root of x squared goes at the front, that's an x, that's an x. Square root of 1 goes at the back, that's a 1, that's a 1. So that's factored. That's how fast it is, but we are going to check this one. We're going to check by expanding here. Let's try it and just make sure. X times x, this is my check line here. X times x is x squared. X times negative 1 is minus x. 1 times x is just x. And 1 times negative 1 is negative 1. These are like terms. A negative x and a positive x cancel out because they make 0, and we're left with x squared minus 1, which is the original question. So I know that I factored it correctly. Almost done. Next one. Is this a difference of squares? So notice the title, difference of squares, really has everything you need to know in it. It's got the word difference in it, which means subtract. Are we subtracting them? Yes, it's got the difference. Are they squares? Yes, perfect square, perfect square. This is a difference of squares. So it's in the form we need it to be in. Now we're going to set up 2 brackets. One with a minus sign and one with a plus sign. And what goes in the brackets? The square root. So the square root of 36 is 6. That's going to go at the front. Square root of x squared is x. That goes at the back. And that's it. That's your answer. We won't check this one, but you can trust me that it's correct. Last one. F is negative n squared plus 9. That looks a little odd, doesn't it? Let's double check here. A binomial, yes, it's a binomial, 2 terms. Does it have a negative sign in the middle? It doesn't. Remember, this one didn't either. But this is unique in that there is a negative sign here. So what I'm actually going to do is I'm going to pick up that negative n squared, and I'm going to just move it over here. So I'm going to rewrite that as, I'm going to put the 9 first. It's a positive 9. I don't need the plus in front. Minus n squared. So now let's check again, because this one did have a subtraction sign or a negative sign in it here. This one didn't. So I moved it over. So now it's a binomial. Yes, it's got 2 terms and it has a negative sign in the middle. So this is good. Are each of the terms perfect squares? They are. So we go over to our steps here. We're going to set up 2 brackets. We're going to put the square roots inside. So 2 brackets. one with a plus sign, one with a minus sign. The square root of 9 is 3, so that's at the front. The square root of n squared is n, so that's the back. And we're going to check this one because this one was a little weird and maybe I messed it up, so I'm going to check just to be sure. Let's do a check here. So first 3 times 3, that is 9. And now 3 times n is a positive. We always put the number first, 3n, not n3. Now negative n, that's a negative n times positive 3 is negative n3, but we have to write the number first, negative 3n. And now negative n times positive n is negative n squared. Oops, I forgot my n there. Squeeze it in. Okay, plus 3n minus 3n makes 0, so I'm left with 9 minus n squared. And is that my original question? It's what I put here, so that's my original question. So assuming that I did this movement over here correctly, which I did, then I have factored it correctly. That's the end of the difference of squares. That's all there is to it. So just remember those 4 steps, which really only takes really one line of work, right? Like this one here, I really just have one line there. I didn't check it. So it's really fast to do the difference of squares. You just have to spend a few seconds first to identify it correctly and make sure it is a difference of squares.